Good morning all. Welcome to the lecture of lattice theory. In the last lecture, we have seen some important definitions to understand lattice theory. And the definitions we have seen is poset, comparability, immediate successor, Hasse diagram, and lattice. Okay, therefore let me recall lattice. Lattice is a poset and is called lattice in an algebraic structure. A poset P with this partial order relation is called lattice if every two element subset has least upper bound and greatest lower bound. Okay, that least upper bound is denoted by x join y, this symbol, and greatest lower bound is denoted by meet, x meet y is greatest lower bound. We have seen some examples also. Okay, we have solved one example by using a Hasse diagram to check whether it is lattice or not. Two examples I have given already. Try to solve both the examples. In today's lecture, let us start with the properties of the lattice theory. Okay, these are the properties we are going to prove. L is a lattice. Then for every A, B in L, prove that A join B is B if and only A precedes B. A meet B is B. A meet B is equal to A if and only if A precedes B. Third one is A meet B is equal to B if and only if A join B. So one side I will write join. A join B is B if A meet B is A. Okay. To prove this first part, we will start with the first part. We will prove the first property. A join B is B if and only if A precedes B. Let us assume, as it is an if and only if statement, we will prove it in two parts. In the first part, let me assume A join B is B. Okay, but what we know, A join B is the least upper bound of A and B. If it is the least upper bound of A and B, one can write A is less equal by the least upper bound. Least upper bound is A join B, but A join B we have assumed B. Therefore, A precedes B is true. Next, conversely, we will assume A precedes B and the aim is to prove A join B is B. We know that with the reflexive relation, B is also precedes B. Therefore, with this, I can write B is an upper bound of both A and B. And we know A join B is the least upper bound of A and B. Therefore, the relation holds as least upper bound is always less equal by the upper bound. Therefore, one can write A join B is less equal by B. Less equal by B, let me call it as 1. But as A join B is an upper bound of B also. Correct, na? As it is the least upper bound, means it is an upper bound for B also. For B, it precedes A join B. Combining 1 and 2, we are proving A join B is equal to B. Similar criteria we will use to prove this relation. That is, A meet B is equal to A if and only A precedes B. Okay, to prove this, let me assume that A meet B is A. Okay, if I assume A meet B is A, one has to prove A precedes B. Therefore, let us start assuming A meet B is A, but A meet B is the greatest lower bound of A and B, set A and B or A and B. Separately one can write. Therefore, A meet B precedes B. But what is A meet B? We have assumed it is A. Therefore, by 3, I will write A precedes by B. One part we have completed. In the second part, we will assume A precedes B and the aim is to prove A meet B is A. Okay. Now, while proving this, we know with the reflexive relation again that A precedes A itself with a reflexive property. Therefore, here one can easily notice that A is the lower bound of A and B, but what we know, A meet B is the greatest lower bound of A and B. Therefore, what is the relation between lower bound and greatest lower bound is less equal. The lower bound we are writing as A, that of greatest lower bound is A meet B. Let me call this as statement number 4. But or also A meet B is lower bound of A and B. Greatest lower bound means it is a lower bound always. Therefore, one can write A meet B precedes A. A meet B precedes A. Let me call it as statement number 5. Okay. Therefore, from 4 and 5, both the relation hold. Therefore, one can write A meet B is equal to A. Okay. Is there any doubt up to this, student side? Okay. Now the third point we want to prove is actually, is my internet working or no?
Yes, ma'am, it is a.
Now the third property we want to prove is actually a combination of these two. A join B is B if and only if A meet B is equal to A. Okay, therefore may I say this property is true from the first two we have proved. Let us check. Okay, A if and only if B if and only if C we have proved. Correct, na? Statement number A, if and only if statement number B we have proved. Then later we have proved C, if and only if B. Therefore, may I say A, if and only if C holds. Correct, na? Therefore, the third one is automatically true from the first two. Correct? So, this is from point number A and B, obviously true. Correct? Obviously true is the reason here. Okay. Always I'm saying now, obviously true is the most dangerous word. Okay. Fine. Is there any doubt with this property? What we have proved? What we have proved? One has to remember only A precedes B is the relation. Therefore, if in this relation, what is the upper bound or join B? What is the least meet, that is greatest lower bound? Hey, this is what we have proved in the theorem itself. So this is over with the first one. Let us go for the second theorem. Now in the second theorem, we are going to verify all the standard properties such as idempotent law, commutative, associative, absorption law, etc. Let me write the statement. If L is any lattice and is any lattice, then for A, B, C belongs to L, prove that. What to prove? First one has to prove idempotent law. Idempotent law. What is idempotent law? Do anyone know? Does anyone knows idempotent laws? Students? Idempotent law? No? What is idempotent law? Let me write. A join A is A. Second one is A meet A is A. This is idempotent law. Number 2 we will write is commutative law. I think one can answer for commutative at least. What is commutative law for this join and meet? A join B is?
B join A.
Yes, this is B join A. And A meet B is?
B
B
meet A.
meet A. Good. Third is associative. Associative law. The first associative I will write is A join B meet C. Yes. No, for associative it is not. A join B join C. That is for distributive actually. Na? A join B join C. Associative we are writing
A
B
join
and
A
C?
join B,
Yes, A join B with
join
join
C. Correct.
C.
Second, similarly for meet. A meet with B meet C is A meet B
A with
meet with
B
C.
meets
Fourth is absorption law. In this absorption law, the element are going to absorb. That's why the name is given like this. See, the law tells us A join A meet B. Therefore, here if you observe, this is somewhat like distributive we have written, where the number A repeats twice, that of number B comes once only. Therefore, this B gets absorbed and the value of this relation will be A. Similarly, this is for A meet A join B is also A. B, this number B is getting absorbed because A comes twice, B comes only once. Okay, let us prove all the four properties. We will start with the proof of first idempotent laws. I think there is no need to prove any idempotent law, no? Because this is quite but obviously true. Because we want to prove actually A join A is A. So let me write what is A join A. Sorry, we have it. What is A join A? According to the definition, this is the least upper bound of the set A and A, which is actually least upper bound of a singleton set A. And what is the least upper bound of singleton set A?
A.
it's A.
A itself. Correct. Friends, the proof. Same conclusion is there for the greatest lower bound. Greatest A meet B is the greatest lower bound of A and A. By mistake, I am writing B. Hmm. Therefore, this is the greatest lower bound of singleton set A. Therefore, this is A. Right? First property true, obviously true. Next, let us go for proving commutative law. Okay, what is commutative? Let me write A join B as least upper bound of the doubleton set A and B. Okay, but whether is there any change if I write this is the least upper bound of the set B and A? Is there any change you find? Least
No,
upper
ma'am.
bound up to 3 and 3 2 is the same one. Therefore, this is same. Therefore, this is nothing but B join A. Similarly, A meet B is greatest lower bound of AB. Therefore, I can write this as greatest lower bound of BA also. Therefore, this is B meet A. Correct. So, commutative law holds. Now we have to do some efforts regarding proving the associative laws because we have not made any efforts while proving the first two. But for proving associative, one has to be very careful. Okay, let me write what I want to prove first. The first one we want to prove is A join B meet C is equal to A join B join C. This is what the aim is to prove. Now let me tell you a hint how to remember the proof of this statement. Okay, we will first start with the right hand side. Okay, that is A join B with join C. And what the aim is, we will try to prove this A join B, this right hand side, is an upper bound of A and B join C. Okay, let me write it with some different color. Okay, to prove this, actually we will prove, just wait. Okay, to prove this, what should we do? Actually, to prove this equality, we have to prove two inequalities going in opposite direction. That is, we will first try to prove this is less equal and greater. Is it this precedes this and this precedes this or less equal? Okay, therefore, what we will do, we will start by considering A join B join with C and try to prove this is an upper bound of A and B join C. What will happen if I prove this is an upper bound of A and B join C? We know A join with B join C is a least upper bound. And here we are proving this to be an upper bound. Correct? So this less equal relation is going to hold. Okay. So let me start to prove. Let me come to my green pen again. Okay, is the idea clear? So let me first consider A join B join with C. Okay, but what we know, this is least upper bound of A join B with C. For this two elements say this will be the least upper bound. If it is the least upper bound, may I say both of them are going to precede this number. Therefore, shall I write A join B precedes A join B join C. Also, C precedes A join B join C. Let me call serially. This is 1 and 2. 1 and 2. Okay, what the fact we know again? This A join B, also A join B is upper bound of A and B. Therefore, shall I write again? A precedes A join B, B precedes A join B. Let me call the number serially by 3 and 4. Now, using these correlation, what we will try to convey, just look at this 3 and 1. A precedes A join B. A join B precedes this. Therefore, may I write A precedes this number, A join B with join C. Okay. Therefore, let me write from 3 and 1. From 3 and 1, may I write directly A precedes A join B join C. Correct? A join B join C. Let me call it as number 5. And the property we have used is transitivity. Correct na? The property we have used is transitivity. Similarly, look at this 4 and 1. Look at this 4 and 1. What 4 and 1 tells us? B precedes A join B. That of A join B precedes this one. Correct? Therefore, from 4 and 1. 4 says B precedes A join B. 1 says A join B precedes this. Therefore, may I write B precedes A join B join with C. Okay, what is the reason again? Transitivity. Correct na? Let me call this as 6. Students, if you are having a confusion, you can just stop and ask me. Okay. Now look at this 5 and 6. From 5 and 6, may I say A join B join with the C is an upper bound of A and B. A join B join C is an upper bound of A and B. Reason from 5 and 6. Okay, now let me use the definition of least upper. Actually, our aim is to prove that this is the least upper bound of A and B join C. A and B we have done. Now we will try to involve B join C. Okay, therefore by definition of LUB of B and C, LUB of B and C, that is B join C. Na? What the definition tells us? What the definition tells us? B join C is precedes by A join B join C. Okay, from 2 and 6 I will write the reason. From 2 and 6. What 2 and 6 tells us? Just look carefully. is C precedes A join B join C. B precedes this. Therefore, this A join B join C is an upper bound of B and C. And this is the least upper from 2 and C. The A join B join C is least upper bound of B and C. Okay, and what we are writing, if this is the least upper bound, this is the upper bound, not least. This is upper bound of B and C, but B join C is the least upper bound. Therefore, the relation I have written, least upper bound is less equal by upper bound. Is this clear to everyone? This is equation number 7. Now from 5 and 7, from 5 and 7, what is 5 I have written? A precedes A join B join C. Here I have written B join C precedes this. Therefore, from 5 and 7, A join B join C is an upper bound of A and B join C. Okay, if this is upper bound, what is the least upper bound of these two? What is the least upper bound? This is upper bound. A join B join C is an upper bound. What is the least upper bound? Least upper bound of these two is nothing but the join of these two. Therefore, this is A join B join C. Therefore, this is what equation we have obtained. One part of the inequality to prove the associative law. Therefore, let me write this as by statement number 8. Okay, let me recall what we have done. Okay, we have started by assuming the right hand side, and our aim is to prove that this is the upper bound of A and B join C, right? To do this, we have started by writing the definition that A join B join C is the least upper bound of A join C and A join B and C. So A join B precedes the number, C also precedes the number. From 3 and 1, A precedes by A join B join C. From 4 and 1, B also precedes the C, right? Therefore, this A join B join C is an upper bound of B join C is an upper bound of what is 2? This 2 and 6. From 2 and 6, A join B join C is upper bound of B and C. A join B join with C is an upper bound of B and C. But what is the least upper bound? Least upper bound of these two is B join C. So the relation I have written, least upper bound is less than or equal to upper bound. Therefore, this holds. Therefore, from 5 and 7, this 5, A join B join C is upper bound of A and B join C. But what is the least upper bound of these two? Whenever we are interested in finding the least upper bound of any two numbers, we should consider the join of the corresponding. Therefore, we have proved this one part of the inequality. Now, similarly, let me go for proving the reverse part of the inequality. What is the reverse part of the inequality? We have to prove here it is greater equal. No? That is A join B join C is less equal by A join with B join C. For the same structure we will consider, we will start with A join B join C, and we will try to prove this is an upper bound of A join B and C. Let us start. According to the definition, this is the least upper bound of A and B join C. If this is the least upper bound, one can write very easily A precedes A join B join C. Similarly, B join C also precedes A join B join C. Okay, let me call it as statement number 9 and statement number 10. But what we know again, now here we have B join C. Therefore, for B join C, may I write but B precedes B join C. C also precedes B join C. Let me call this as 10 and 11. Okay, now B precedes B join C. B join C precedes A join B join C. Therefore combining, oh I have given wrong number. Here it is 11, here it is 12. Okay. From 11 and 10 and 11. From 10 and 11. What we have proved? B precedes B join C. B join C precedes this. Therefore, B precedes A join B join C. Reason is transitivity because it is not less equal. No, it is less equal. It do actually. Okay. Now from this second one, C precedes B join C. B join C precedes this. Therefore, what numbers are there? 10 and 12. From 10 and 12. For 10 and 12 tells us C precedes B join C. B join C precedes this. Therefore, may I write C also precedes A join B join C with similar reasoning of transitivity. With similar reasoning of transitivity. Okay, therefore from these two, may I say A join B join C is an upper bound of B and C. But we want to prove this is an upper bound of A join B and C. Okay, let me write by definition of least upper bound of A and B. That is from you look at this 9. A precedes A join B join C. Okay. B also precedes the same. I think I should give the numbers to this also. 10, 12, this is 39, right? So every statement we have to give number. Every statement is useful. Therefore, let me write 14 also here. 13 and 14. Therefore, what 13 and 14 says? That is A precedes A join B join C. A precedes A join B join C. B also precedes A join B join C. Okay. What are the numbers? A precedes 9, 30. From ending and rub this from 9 and 13. A join B join C is an upper bound of A and B. Correct na? A precedes A join B join C. B also precedes A join B join C. Therefore, this is an upper bound. But what is the least upper bound of A and B? A meet B na? What is the least upper bound? Sorry, A join B. Okay. Therefore, may I write least upper bound precedes upper bound, and the least upper bound of these two is A join B, which precedes A join B join C. What is the number? 14 I have given already, therefore let me call it as by 15. Okay, now look at 14 and 15. Look at 14 and 15. What 14 says? C precedes A join B join C. 15 says A join B precedes this. Therefore, this A join B join C is an upper bound of A join B and C. Upper bound of A join B and C. What is the least upper bound? Okay, let me recall from 14 and 15. From 14 and 15, A join B join C is an upper bound of least upper bound. So let me write least upper bound is less equal by upper bound. Upper bound we know A join B join C. Now what is the least upper bound? Least upper bound is A join B join with C. Hence we have done, and this next number is 16 I think. And what is the first one? We have written a number 8. 8 and 16. From 8 and 16 we have proved A join B join C is equal to A join B join C. Hence the proof. Any doubt with the proof of this associative law? If you have a doubt, you can ask me. Students, the trick you have to remember is by proving both. Okay, in the first part, if we start with the right hand side, A join B join C, only the aim is to prove this is upper bound of A and B join C. If once we prove upper bound of this, less equal this less equal hold. To prove the reverse inequality by antisymmetry. Reason I have forgot here. 14 and 14. Here it is. What is the property we have used? A related to B, B related to which property? Antisymmetry, no? Yes or no?
Yes, ma'am.
A related to B, B related to A implies A is equal to this property we have used. Okay. This may feel confusing to you, the proof, but if you do a practice once or twice, it will be, there is no problem while letting the proof. Okay. The proof of join I have given you. For the second one, for the meet you have to write on your own by similar methodology. Okay. Therefore, let me go for the next fourth property of absorption law. What is absorption law? First, to prove that A join A meet B is equal to A. Okay, therefore here A repeats twice, B comes once, therefore B gets absorbed in A. Okay, now to prove this, what we will do? We will start to prove that A join A meet B is least upper bound of A and A meet B. Okay, let us start. Since first I will write A precedes A, reflexive. Next I can write A meet B also precedes A. Reason A meet B is GLB of A and B. Okay, therefore combining the two, may I write A is an upper bound of what? A and what? Least upper bound is join, na? A join A meet B is least upper bound of A and A meet B. Okay, then what is the relation between upper bound and least upper bound? Least upper bound is less equal by upper bound. If what can I write? A, yes, this is least upper bound, this is any upper bound. Therefore, A join A meet B precedes A. Let me write as equation number 1. Correct, na? But what is the definition of LUB? By definition of LUB, A join A meet B is LUB of A and A meet B. Correct, na? If this is LUB, wait, please get zoomed. Therefore, if A join A meet B is LUB of A and A meet B, may I write A also precedes by A join A meet B. Therefore, let me call this as 2 from 1 into from 1 into A join A meet B is equal to A. Hence the proof. Correct. Now to understand this statement, A join A meet B is least upper bound of A and A meet B. Therefore, A always precedes by A join A meet B. Therefore, this is going to hold. Let me prove second one. A meet A join B is equal to A. We will start with the similar steps. A precedes A reflexive and A also precedes A join B because A join B is LUB of A and B. Correct now? Therefore, what this implies, A is lower bound of A and A join B. But what is the greatest lower bound? A meet A join B is greatest lower bound of A and A join B. And what is the relation? Lower bound less equal by greatest lower bound. Correct. Therefore, here I can write A less equal by A meet A join B. Let me call this as statement number say 3. Again, but by the definition, this by definition A meet A join B is GLB of A and A join B. Therefore, may I write this is greatest lower bound of A and A join B. Therefore, may I write A meet A join B. A meet A join B precedes A also. Let me call this as statement number 4. And from 3 and 4, equation holds. From 3 and 4, A join A meet B is equal to A. Hence the property holds. Any doubt with this second theorem from student side? Any doubt from student side? Okay, if not, let me go for one more theorem. Theorem number 3. Theorem says that if L is lattice, then prove that. Then prove that for any A, B, C, D belongs to A. First one to prove. A precedes B implies A join C precedes B join C. Next, A precedes B implies A meets C precedes B meets C. Third, A precedes B, C precedes D implies A join C precedes B join D. Fourth, A precedes B, C precedes D implies A meets C precedes B meets D. Okay, now the proof of these theorems are not confusing ones. Let us prove. To prove this, we have to keep the previous theorem in mind. What the previous theorem we have proved just now? A precedes B will give us A join B is B and A meet B is A. Correct now? This point you have to keep in mind. Or by Hasse diagram, this was a situation. A precedes B. Therefore, the above element will be the join and this below one will be a meet. Okay. Once you understand this fact, one can prove this result very easily. Now let us go for proof of the first one. I will consider A precedes B. Okay. If A precedes B from theorem 1, and write the things again. A join B is equal to B implies and implied by A precedes B. Let me call it as statement number 1. Now consider the fact we want to prove is actually A join C precedes B join C. To prove this, what I will do, I will prove the join of these two. The join of these two is B join C. Correct, na? See, whenever I want to prove by the previous theorem, if I want to prove X precedes Y, then try to prove what one has to try to prove. X join Y is equal to Y. Correct na? Therefore here what I will assume, this I will assume X, this I will assume Y, and to prove this X precedes Y, I will find the join of them and I will prove the join is this Y. A join C and B join C. Consider, I'll change the color. Consider A join C join with B join C, and the aim is to prove it is B join C. Okay. Now we have all the laws with us: commutativity, associativity. So for using these laws, idempotent, using these laws, we will try to prove it as B join C. Okay. First, I will use commutative here. For A join C, join with C join B. The first property I have used is commutativity. Here I have used. Okay. Next, what I will do? I will use associative to combine the middle two C's. This is A join, C join C, join B. Reason associativity. But what is C join C? We have already seen. This is C itself, na? Reason idempotent. Therefore, the statement we have is A join C join B. Therefore, I can write as A join C join B or A join B join C. Correct. If I write here, I have used commutativity again. Now, this B join C, what I will try to write by using associative, this is A join B join C. Reason associative I have used. But what is A join B? A join B is B according to our statement. Therefore, this is B join C. Hence the proof, we have proved X join Y is Y. Therefore, X precedes Y. Hence, A join C precedes B join C. Okay. Similarly, we will prove the second one. What we want to prove in the second? A precedes B, A meet C precedes B meet C. Correct? A precedes C in A meet C precedes B meet C. Okay. Again, to B implies and implied by A meet B is A. Let me call it a statement number 2 by previous theorem. Again, here we want to prove X precedes Y. Now we have meet in hand with us. So instead of proving with the join, I will prove it with meet. Okay. Therefore, X meet Y, I will prove X. Correct na? Again, I will write here. To prove X precedes Y, we will try to prove X meet Y is X. Correct? Not to be included in the proof. Actually, you are not writing proof anywhere, therefore there is no confusion. So let me consider A meet C meet with B meet C, and the aim is to prove this is A meet C. Then the result is going to hold. Again, which laws we have with us? Commutativity associative. I will use commutative again. A meet C meet with C meet B. All steps are going to repeat. For join, replace with meet. This is A meet C meet C meet with B. Which law I have used? Associative. Now let me use idempotent. This is A meet C meet B. Which law? Idempotent. Now we have A meet C meet B. Now what I will do? I will write A meet Yes? In doubt with these proofs? Students side, any doubt? If you have a doubt regarding any concept, you just stop and ask me. Okay. Third point we will take. C precedes D implies A join C precedes B join D. Okay. The same conclusion we are going to use. Before that, we will write what is the meaning of these two. Okay. First, I'll write A meet A precedes B implies and implied by A join B is B. Let me call it as 1. C precedes D implies and implied by C join D is equal to D. Let me call it as statement number 2. Now we will, to prove this X precedes Y, I will consider the join and we will prove the join is B join D. Consider A join C joined with B join D. Correct na? Many laws with us again. If I will use associative first, A join C join B join D. Associative. Then I will use commutative. B join C here. Commutative. Next I will separate again. A join B join with C join D. But what is A join B? This is B from 1 and this is D from 2. This is from 1 and 2. Okay. Last point we will prove that A precedes B, C precedes D implies A meet C precedes B meet D. Everything is with meet. Therefore, first we will write the statement A meet precedes B implies A meet B is A. C precedes D implies C meet D is C. What the number is? I can continue from 1 again. 1 and 2. Okay, now should I consider A meet C meet with B meet D and the aim is to prove it as A meet C. Therefore again using the properties A meet C. What should I use first? Associative I will use. A meet C meet B meet D. Should I use commutative now? B meet C. Meet with D. Again associative. A meet B meet with C meet D. But what is A meet B? A. C meet D. C. So this is A meet C. What we have proved? X meet Y is X. Therefore, X precedes Y. Very nice and interesting proof actually for the lattice theory. I like these proofs very much. If you have any doubt, you can stop. You can unmute yourself and ask me. Today we'll stop here. In the next lecture, we will go for the remaining properties and next points also. Yes, any doubt? Today's lecture? 17 students are there with me till now. Thank you for watching the lecture.